G and I didn't realize or didn't read the materials to find out this conference was about visualization. So we're not going to talk about visualization today. Yeah, that's good. Oh, yeah, we could. Yeah. Although I did have a story I wanted to tell about visualization. And this is from many years ago when I was an assistant professor, the great cognitive psychologist Herbert Simon, who was one of the only psychologists to ever get the Nobel Prize. He used to be the only one until, I guess, Danny Kahneman. But he came and gave a talk where I was teaching at the University of Chicago at the time. And he had a big audience, of course, because he was very famous. And he was presenting a study. And when he got to the point he wanted to present some data, he turned around and went over to the chalkboard and he drew an axis and he did the points. And he had his back to the audience the whole time. And he carefully looked at his data and plotted each data point. And I met with him afterwards because he was meeting with different faculty. And I said, gee, I've never seen anyone do that before because most people just put a slide up. I said, why do you do that? He said, because that's how long it takes someone to understand a graph. And I thought, and that's actually my experience today in some ways also, because we've looked at so many visualizations, and even though I look at a lot of them, it takes time to understand a graph. So anyway, today what we're going to do is G and I are going to talk about course kata, and in particular, this project we've been working on for the past, how many years? 7 years or so? Okay, don't say that. And I'm going to give the first half of the talk. Hopefully it'll be less than half the time, and then G is going to take over from there. But a little bit about course kata and what we call the better book approach. First of all, it grew out of a joint lab that G and I have run for many years at UCLA and Cal State LA called the TALL Lab, the Teaching and Learning Lab. And our focus is on understanding and improving how students learn things that are hard to learn. And the insight we had is so much of psychology is focused on things that are actually easy to learn because you have to teach it to them within that 1 hour experimental session. But things that we really care about, like statistics or mathematics or STEM, or a lot of things, you don't learn them in an hour. In fact, you learn them over months and years. And there are things about statistics I'm still continuing to learn because I'm in that field. So anyway, Course Kata was our attempt to figure out how to build an R&D system for improving students' learning of statistics. So we started out with 2 starting points. One was a problem and the other was a theory. And these were things that G and I had developed over time through many, many arguments, which were very, very fun. And I think our students were a little scared by that because we would really argue a lot, and it was great. So the problem we started with is statistics. Statistics is a complex domain. It's hard to learn. 1.5 million, this is according to data from Digital Promise, 1.5 million students every year take introductory statistics. A third of them fail. That's actually inconceivable because I know a third of my students don't fail. But that's across all kinds of college settings in the United States. We're just not good at it. The other reason we chose statistics is because G and I both teach statistics. So we're not statisticians. Actually, we're the opposite. We're novices. So that's one of our advantages, our super strengths. But statistics, is very related to visualization. And a lot of things that our students struggle with are learning how both to make and interpret visualizations of data. So starting with the problem, we also needed to start with a theory. And I don't have time to digress a lot, but I think it's very important when you're doing this kind of work to have some sort of theory. And a lot of people wouldn't call our theory a theory, but what it is sort of a visualization of sort of an end goal of an idea that we really want to follow through and find out whether it has legs. And we call this the practicing connections hypothesis. And it's based on our own experience of teaching statistics. When we teach statistics, we teach a whole bunch of different things in introductory statistics. If any of you have ever taught it, this is just a very subset of the things. We teach statistics and parameters and t-tests and ANOVA and regression and chi-square and all that. But what we realized over the years is although our students get so they can answer questions about what each of these things are, what they're not able to do is put them all together and coordinate these ideas in a coherent way to transfer to new situations and actually do the kind of work that they're hoping to be able to do, like do a data analysis or also take the next statistics course. So this is our insight, is that students are learning the bits, but they're not learning the connections. So why might this be important? Well, this is not an actual fMRI plot or anything. I actually drew this on PowerPoint. But the whole idea is, hey, if you know the person on the left and person on the right, they know the same things. But the person on the left, it's all disconnected. So let's say you give that person on the left a new problem, and he needs to somehow find his way to that idea B that's going to help him solve that problem. He really doesn't have a way to get there and connect it to where he is. He has a very strong connection to E, but that's not helping him, and D, etc. The guy on the right has a very highly interconnected and coherent set of connections that tie together all the same things. And so if he's presented with the same problem, he's trying to get to B because he needs that idea to solve the problem. He has, as you can see, multiple pathways he could take to get there. So why is this important? Well, we believe there's a lot of literature in cognitive psychology over many, many years that shows that connected and coherent knowledge is going to be more transferable to new situations. And then we had this idea, which is, hey, if what people find hard to learn is the connections, why do we spend so much time having them practice the bits? Why don't we see if we can have them practice the interconnections over time and therefore develop a more coherent knowledge base? All right, so there's our problem, and there's a theory that we're really interested in. And the question is, how are we going to go about advancing our understanding of these ideas? And we came up with this idea that we called the better book approach. So I'll tell you a little bit about what that is, and G is going to tell you some of the things we've been learning. But first of all, I want to contrast it with sort of the traditional way that educational programs are developed. First of all, there are these silos. So you have researchers, and they're smart people like us, and we come up with theories and ideas and all that. And what do? We write journal articles. And who reads the journal articles? Well, basically no one, hardly anyone. But we expect that they should. Many psychologists are quite mystified that teachers don't use their amazing theories in the classroom. And teachers are mystified as to why researchers think these theories are so useful. There's a huge disconnect. And these silos really prevent you from taking an idea and pursuing it out. So what we decided back in 2017 is, hey, instead of having faith in this idea that research is going to somehow lead to improvements in education, why don't we actually change it into a different kind of process where we have the three groups of people that we think are really critical here: researchers, designers, and educators or instructors, and also students. And instead of having it be, oh, we hand it off, instead we all collaborate on building a set of materials and then engaging in the continuous improvement. So there's really two parts to our project. First was to create version 1 of an interactive online statistics textbook that could be used for college. And we now use it in college and in high school. So we have a number of students. And to implement that at scale. And then the second thing is, once we have it implemented at scale, is to figure out how to do research on it and do continuous improvement of it. It's based on this really important idea that if you have an innovative idea in education, and practicing connections is innovative in the sense that it's very countercultural, because people don't think that way. In fact, if you look at modern technology-supported educational systems for teaching, they're all based on this BITS idea. It's all about, hey, we divided it up into 150 micro-objectives, and we're going to give them to you on a spaced practice schedule, and we're going to expose you to them if you forgot them, et cetera. So, but if you can't take an idea like that and implement it at scale, then you can't even study it and see if you can figure out if the idea has legs. So G and I are pretty humble. We don't look that way, especially G, but we actually are. We don't necessarily think our theory is right, but we think it's definitely an idea that's worth exploring. So 2 components, creating version 1 and then doing this continuous improvement. So creating version 1. This is really hard. We had this idea and we could have written an article about it. Actually, we did. But to actually use an idea that and implement it in the context of a educational program that's going to be used by thousands and thousands of students is really hard because you realize it's not that easy to figure out. For example, practice the connections makes a lot of sense. Well, what are the connections? Because everything is interconnected. And that took us about a year to argue about what would it even mean to practice connections. And we were inspired by my guitar teacher, Igor, who I took jazz guitar from for 15 years. And Igor told me at the very beginning, in my first lesson, he said, jazz is very easy. There's only 5 chords. And if any of you have ever played the guitar, you've seen those books like 10,000 guitar chords for jazz. And I'm thinking, only 5 chords? He said, sure, I'll teach them to you today, and then you can play jazz. So don't worry about it. And if you're interested later, I can tell you what the 5 chords are, because it's magical. Although I did share that with, there's a very famous jazz guitarist who was on the faculty at UCLA for many years, Kenny Burrell, one of the most famous jazz guitarists. And I said, I've been studying jazz guitar and I learned about the 5 chords. He said, what's the 5 chords? And I said, the major 7, the minor 7, the minor. He said, that's ridiculous. But I also realized that what are the important concepts or chords to organize the domain for a novice may be very different from the ones that are used for an expert. So G and I had this idea of setting out to, better hurry, to see if we could figure out what are the 5 chords for statistics. What are the core concepts that we could connect everything to in order to help students connect the ideas together? And the idea we came up with was basically statistical modeling. Everybody knows that statistics, modern statistics, is about modeling, but you never hear that word in the introductory course because people think, you got to learn the basic bits first, mean and standard deviation. And we said, hey, maybe we can teach mean as a model right from the very beginning. Standard deviation is a measure of error from around a statistical model, and so on and so forth. So that was our idea, is to build a textbook that absolutely, to the best of our ability, engage students in practicing these connections. Everything in the book, and we went from exploratory visualizations to modeling and inferential statistics and everything connecting it to the idea of models and model comparisons. So it meant certain topics that everybody learns in intro statistics, like the t-test. We formulated not as a t-test, but as a comparison of 2 statistical models. One is the empty model, which is just the mean, and the other is a 2-group model. And that F-test you get, and you take the square root, it's the t-test. But we see the value in having everything be tied together. Once we had this version 1 of our curriculum, we set about this work of continuous improvement. And to do that, you need settings to do the work, you need protocols to guide the work, and then we needed a technology platform to support the work that we were doing. The setting that we have is really incredible because it's now students all over the world using our curriculum and generating huge amounts of data, but we also needed to attract outside researchers like Judy Fan, for example. How do we get her engaged in course kata? The protocols we use for improvement, there's a whole field of improvement science, and we started working to implement improvement science methodologies on the continuous improvement of our textbook and also the supporting materials. And then technology. We had to build a platform that would allow us, for example, this is something, thinking about with Ben Motz's work on terracotta and all that. you know how hard it is to get data out of a learning management system. So we thought maybe we should just scrape the data out before we send it back to the learning management system. But then there's all kind of data privacy. And so we had to deal with all that and build a platform that would do that. The way I like to think about Course Kata is like the International Space Station. If you're interested in studying how seeds grow in a zero gravity environment, and you have an idea, you might try to get your experiment up on the International Space Station, but there's no way you're going to get a grant to build an International Space Station. And so I look at Course Kata as, hey, it's like an International Space Station for studying how people learn hard things. And in fact, what we're doing now is attracting, I think, probably 5 or 6 research groups around the country now, active research groups, as you see from the work that's gone on with Judy's group, and have them do their work in the Course Kata setting that we've developed. And I'm going to let G now tell you a little bit about what we've learned.
Right. And it's okay if I do a terrible job, because Alice and Christine are going to come after me and they're going to really clean it up, because they're going to really show what kind of research you could do in the Course Kata community. So we built the International Space Station, but it was duct taped together with a bunch of grants. And each grant wanted us to do different things, but we had our eye on the prize, because nobody really wants us to build the International Space Station. But once we built it, then we started learning stuff. And people were like, wow, it's a good thing you built that. So I want to show you a little bit about what we built. We have a 12-chapter textbook used by over 100 institutions, thousands of introductory statistics students on it, many teachers. And in that textbook, we have a number of measurements built in. We have responses to actual statistics questions, because we are interested in that. And it turns out that interpreting a scatter plot, like thinking of income on the x-axis, is not something that comes naturally to infants, right? You have to learn that somehow. And this is how they learn it, in class. We also have engagement, things like how much time did you spend in our textbook? Where do you click? What do you do? We also have a bunch of psychological constructs, surveys, and I'm going to talk a little bit more about those. So I want to position you in my world, right? We're not going to talk about data visualizations. We're going to come at it from the perspective of people who genuinely care that people understand data. And these are instructors, these are students, these are people in the world who realize, wow, people are not good at this. We want to help them be better. And so introductory statistics provides us a vehicle to do that. And based on that, we could actually improve the course materials with data instead of just feeling like, I think that worked, because I'm the instructor and I worked really hard and I had an N of 1 class and I feel pretty good. My students like me. Not good enough, guys, right? Let's not do that. We can also improve course materials with research design, like A/B tests, right? We could also improve course materials with community, because it turns out each of us only feel a little bit of the elephant. And we don't know what's going on in the rest of the elephant. And when you bring the rest of the community, the other stakeholders in, you're like, oh my God, this makes so much more sense. And our constant challenge is improving the implementation. The innovation is like, as Jim says, 20%. That is a number he made up. But implementation is really the rest of it, right? And that's what we're really interested in. So first, what do we mean by improving course materials with data? And I want to show you a data viz example. For example, we try to teach people the 5-number summary and what the hell quartiles are, right? That is not a natural idea for students. We say it's important to note what is equal about the 4 quartiles is the number of data points included in each. How much clearer can I say it? And then we show them this visualization. And as visualization researchers, you might immediately see the problem with this. And we ask students in that same page, the quartiles are equally sized. What is equal about the quartiles? And about 50% of students used to say, They each have the same number of data points. But look at the wrong answers, right? They say things like they have the same range, they have the same interval. Whose fault is that? Oh no. And so we want to make changes that could impact students. Teachers suggested a better visualization. So same text, but the visualization targets that misconception. Now we're showing an example where the quartiles really have different size intervals. Is that change an improvement? That's the key. And this is just a quasi-experimental study because you know what? It turns out every semester you got a whole new crop of people taking intro stats. And so we have a new crop of students. And indeed, you could see that more students are getting the correct answer. And importantly, they are avoiding the misconception that we were targeting. But sometimes data make us sad, because just because you collect data doesn't mean it's all good news. Like, for example, we have a number of videos. Turns out nobody watches them, right? And people are always like, oh, you should put more videos. Why? So that more people could not watch them? No, thank you, right? But then we ended up asking teachers, hey, nobody watches these videos. And you know what they said to us? We show them in class. We watch it once. And we're like, that's why you got to bring in the rest of the community. The data don't necessarily tell you what you think it means. Then we could also not just use data, but we could use the rest of research design. Hell, some of us even teach that class, right? Why not use it to improve the teaching? And so this is really what I like to call the IC saying showcase. So if you have any questions about my glib summary of all her amazing work, please go see her after this. Here's the thing. We have this as our little logo because we really believe in research design. We really believe that by having control group and an experimental group that we could learn something causal, right? So that's what we do. We have in our platform the ability to do randomized control trials within classes. So each student gets slightly different versions of a visualization, of a paragraph, of videos in this case. And so here we have the control condition. They got business as usual. In the experimental condition, they got specific videos to help students make connections, sound familiar, across particular data visualizations that we knew students had a hard time connecting. For example, box plots and histograms. Students do not naturally see, wow, that's the same data. Even when they literally write the R code from the same data set, they're like, oh, this is like really different patterns. No, it's not. So how do we help them see? IC and her team created representation mapping videos to help students make those connections across superficially different visualizations. And then they could see, are those videos making improvements on their ability to understand these different visualizations? And so they could look at the immediate performance within chapter 3, where they actually put the videos in. That was our data visualization chapter. Not only that, but here's the implementation problem. Just because you randomly show people give people the option to have additional videos, doesn't mean they click on them. And clicking on them is causally related to watching them, it turns out. And so that's science, right? And so what we could see is that the number of videos you watched actually relate to the benefits you see in those representational mapping videos. For us, that implementation is part of the problem we're interested in. We're not just like, good job making videos that no one watches. That's not the solution. We also want to figure out, hey, why don't students watch the videos, right? IC has additionally done multi-week classroom interventions where she has students not only perform specific actions on representations, but she also has students watch them as observers to understand the cognitive implications of actually doing the thing versus simply watching the thing. And she did this across a 10-week course. And so they were in pairs, but randomly assigned to be either a performer or a recorder for many, many different activities across a 10-week statistics class. And there was this way of she did assessments where she got assessments both that were pre-assessment to the content being learned, but also functioned as post-assessment to the last week's content that was learned. And I'm going to go over this a little bit fast because I'm running out of time, but the big message is that it depends on the learner's background knowledge. If the learner has a lot of background knowledge, and that's what's represented on the x-axis, and I want to note, perform is the doing stuff. That is the red line, and the observe is the blue line, right? Let's look at the observe first. Those students, we see largely a pattern that is replicated across all of education. The more you know, right? People who come in with less background knowledge do worse than people who come in with more background knowledge. That's business as usual. But when they start doing these perform activities, then that correlation gets wiped out. Now you're starting to see more of an equal playing field. Regardless of what background knowledge you came in with, you're seeing similar effects. But what's really exciting to me is the fact that Jim and I are frequently wrong. We don't know everything. And so it's really having course kata researchers, people like Christine and Alice and Eric and all these other people. This is just a scattering of them, right? As well as our teachers, high school teachers and college instructors. They really show us the way. And I don't have much time, but I just want to give you one example of what we can do when we gather all those people together. We talk about changing educational systems in order to do systemic justice. And education really is a system. But in psychology, we often treat it as an individual change problem. Like, I'm going to try to do something to you that makes you different. But there's another thing we could do. We could change the whole system and see if everybody who passes through the system has different outcomes. And so this Better Book model really is trying to stand up an example of that systems change approach. That's a hard thing to do, but we think that by getting all these people together to work on the course materials, we're changing the system itself. And so remember I told you there's these psychological constructs. Some of these constructs are motivational. And so we have what are called pulse checks in front of every single chapter where we ask about a bunch of things. But the two I want to just point you to are utility value, which is like, how useful are you finding this thing that we covered in the previous chapter, as well as cost, which is it worth it to learn it? Because dang, all this is hard and it takes time. Is it worth it? That's what we mean by psychological cost. And one of the things we could do is we could see, hey, are there motivational gaps between Black and brown students? That's in the lower kind of light blue line, or non-racially minoritized students, white and Asian students, right? And so here we see that in a lot of these motivational measures, utility value being one of them, we don't see a difference. Where we do see a big difference is cost. Is it worth it? And racially marginalized students are saying, it's too much cost. It's not worth it. And so we focused in on these hotspots. And remember, these are asked at the beginning of chapters. So when we say chapter 8 has a hotspot, it means that they're reflecting on their experience of chapter 7. And so I want to just point out that this kata visualization is the worst visualization ever. Right? Because you have to look at it in this crazy ass order that does not make any sense to any human on earth. But we still think it's useful for organizing our vision. Because first, you have to get a vision or direction in which to go, in which to get all your different constituent parties to try and walk towards. And for us, in this project, it was about equity in terms of motivation, engagement, and learning. And I'm just going to show you motivation. The current condition was that, man, we have a gap. We don't have equity. And so our target condition was, let's have more equity and let's focus in especially on chapter 7. We redesigned the book based on the voices of students and instructors, but more importantly, we evaluated it. So I'm not going to say what we did. There was a bunch of stuff we did, but the good news is, take a look at this cost gap. We used to have a cost gap. After our redesign, it's squashed down. We only have a gap left in chapter 3, and that's what we targeted this past year in version 5.6.2 of our book. And so the whole point of the Better Book model is that we want to put these research insights into the instructional materials that could be deployed at scale, right? Instead of writing papers, let's put it into the things that the people will actually run into in the world. Thank you.
All right, thank you so much.
So this idea of running RCTs to improve the textbook, I imagine there are just many possible RCTs that you could run, but you need to pick some. So I wonder if you are committed to psychological theory, or you are thinking with teachers, or I wonder how do you go through this process?
Yeah, in some ways, that's what we're also trying to do, to change the cultures of researchers, change the cultures of teachers, and change the cultures of developers. Because each of those constituent parties have their own little goals. And we're like, we can't do all of them, right? So in some sense, what we're trying to do is change the culture so that we really can work together. And that's why that setting of the vision is super important. And that's why we really believe in gathering as a community to figure out what those research priorities really should be.